Dear friends, I myself, Dr. Bharat Parab, discussing the topic playing with numbers. Very interesting topic. We have seen two videos on this, and this is a third video and last video. And subtopic of this is a test of a divisibility. Okay, what does this mean? See, it's given in the form of comment. We know how to check a divisibility of any number by certain divisors as 2, 3, 4, 5, 6. It doesn't contain 7, 8, 9, 10, 11, like that. What does this mean? That means if any number is given, any big number is given, then by certain tests or certain rules, we can check whether or judge whether the number is divisible by 2 or 3 or 4, like that. Okay, so the comment here also says that that means if number has a last digit or unit place digit as 2, 4, 6, 8 or 0, then number is divisible by 2. Or if last digit is 5 or 0, then the number is divisible by 5. We know this. We know for 3, we know for 4, for all. Okay. Now the question is, we are going to study why it works. This question we are going to answer. We know it works. Now why it works? Okay. So first test under this divisibility by 10. So read this comment, go through this very thoroughly. We all know that numbers containing a 0 at the end or at the unit place is divisible by 10, so that uh, we see these numbers 10, 20, 30, 50, like that. All these numbers are divisible by 10, and the numbers like 16, 22, 34, all these numbers are not divisible by 10. Okay, now we have to answer this question, why? Okay, so for this, let us consider three digit number in general form. Okay, any three digit number, CBA. Okay, so that you can study this. So this is a number. We have continued this in the next slide. So we will move to the next slide. Okay, so we are continuing from the last slide. Go through it. So let us consider three-digit number in a general form as CBA. Remember the form CBA. This number can be written as, CBA is written as 100 into C, okay, plus 10B plus A. That means 100C plus 10B plus A. We are familiar with this. Now look at it. A is 1st digit, this B is 10th digit, and C is 100 digits. Okay. Now see, as 10 and 100, this and this are divisible by 10. Okay. 100C and 10B are divisible by 10. Okay. Got it? But for the whole number to be divisible by 10, A has to be 0. Getting this argument? Very interesting argument. If this is 0, then the whole number will be divisible by 10. Remember, this is 0, this split, and this divisible by 10, and the whole number will be divisible if A is 0. If A is 0, then and then only CBA will be divisible by 10. Okay, any number is not possible. That means for any number to be divisible by 10, units place digit must be 0. Got a very interesting and very intelligent argument. And this by this we will try to see what arguments we are going to study for other divisibility. Okay, so we move ahead. Second one, divisibility by 5. We know the numbers are divisible by 5 or numbers multiples of 5 are 5, 10, 15, 25, 65, 90. Okay, all these numbers. As we have seen earlier, consider three-digit number CBA again, which can be written as, you have seen this, CBA can be written as 100 into C plus 10B plus A, where 100C plus 10B plus A. Okay, seems to be same argument. So we can see that first two 100C and 10B terms, first two terms, this term and this term are divisible by 5 because this contains 100, they multiplied by 100, this is multiplied by 10, so they are going to be divisible by 5. For the whole number to be divisible by 5, a at the unit place has to be 0 or 5. Got it? We know it is, if at the end if it is 0 or 5, this is divisible by 5. But here the argument is, if a is a 0 or 5, then and then only the whole number, that is this number, is divisible by 5. That means for any number to be divisible by 5, its unit place digit must be 0 or 5. Okay, got it? Same as we have seen for 10. Okay, so we move ahead. Third one, divisibility by 2. We know the numbers are divisible by 2 or numbers multiples of 2 are 2, 4, 10, 14, 26, 60, all these numbers. As we have seen earlier, consider a three-digit number, again same general form is taken, CBA, which can be written as CBA is 100 into C plus 10B plus A, that is 100C plus 10B plus A. As we can see, first two terms, this and this, 100C and 10B are divisible by 2 because they are multiplied by 100 and 10 respectively. For the whole number to be divisible by 2, then A in the unit place has to be 0, 2, 4, 6, 8. Got it? Then this number has to be divisible by 2 and this is divisible by 2 if this is either 0 or 2 or 4 or 6 or 8. That means for any number to be divisible by 2, its unit place digit must be 0, 2, 4, 6, 8. Okay, so this is argument for this and is found to be true. Okay, so we move ahead. Fourth one, divisibility by 3 and 9. Go through this comment. Divisibility of 2, 5 and 10 are very easy to determine as we have to check only last or unit place digit. We have seen this, whether any number is divisible by 2 or 5 or 10, we have seen only last digit and decide it. Okay, we have seen this. But divisibility of 3 and 9 is checked by a different way. And this is a way. Let us, before going for the general example, we will check one actual example, actual digits. So consider we take some number, consider the number 2358. Okay. Now the expanded form of 2358 is 2358 equal to 2 into 1000 plus 3 into 100 plus 5 into 10 plus 8. This is very easy as we have seen this many times. Okay. Now we are making some change, that we are writing this 1000 as 999 plus 1. Okay. Why? Because this number is divisible by 9. You have to check for some method. Okay. So 1000 is written like this, 100 is written 99 plus 1 and 10 is written 9 plus 1. Okay. Remember, we are not changing any value. We are not supposed to change any value. We are only rewriting it in different form. Okay. So 2 into 999 plus 1. plus 3 into 99 plus 1 plus 5 into 9 plus 1 plus 8 remains as it is. Now take this 2 inside, 2 into 999 plus 2 into 1 plus 3 into 99 plus 3 into 1. This is very simple arithmetic. 5 into 9 plus 5 into 1 plus 8. Okay. Now next step, just see 2 into 999 we are keeping it as it is. 2 into 1 is 2 plus 3 into 99 we are keeping as it is. 3 into 1 is 3 plus 5 into 9 here and 5 into 1 is 5 plus 8. Okay. So till here it is very simple now. Now we will collect all these 9, 9 and 99, all these terms together. So 2 into 999 plus 3 into 99 plus 5 into 9, keep them all together and bring other terms together. So what remains here is 2 plus 3 plus 5 plus 8. So keep them in a bracket. Okay. So got it? So we have kept this number in a bracket. If you see this 2, 3, 5, 8, this is same number 2, 3, 5, 8. Okay. So first three terms are divisible by 9 because 999, 99 and 9 we know. So these terms are divisible by 9 and also by 3. Okay. But if the given number, that is 2358, 2358 will be divisible by 9 and 3 only if addition of all this 2 plus 3 plus 5 plus 8 is divisible by 3 and 9. Okay, got it? This is divisible individually. This is divisible. The whole number will be divisible if this is divisible by 3 and 9. So in the present case, see 2 plus 3 plus 5 plus 8 is equal to 18, which is divisible by 3 and 9. Hence 2, 3, 5, 8 is divisible by 3 and 9. Okay. So what do we conclude? We conclude is we conclude that if the sum of all the digits of the number is divisible by 9 or 3, then number is divisible by 9 or 3. Okay, that is the conclusion we are drawing from this, and we will go for the general form. Before that, we have just seen this how this is very simple. Okay, so we move ahead for the general form. Okay. So in general, consider the number CBA. We have seen for 4-digit number by considering actual numbers. Now we are taking general form CBA. Now this number CBA can be written as 100 into C plus 10 into B plus A. Now the 100 is written as 99 plus 1 into C plus 9 plus 1 into B plus A. You know till here. Now we are taking C inside, 9 C plus C plus now B inside, 9 B plus B plus A. Now we are collecting these 9 terms together. So 9 C plus 9B plus C plus B plus A. Okay. And just rearranging it. You need not rearrange, but I'm just rearranging them. Okay. Now take 9 common. What remains into bracket is 11C plus B, which is marked in yellow, plus A plus B plus C. Okay. So go through the comment here. The 9 into bracket 11C plus B is divisible by 9 or 3. But if A plus B plus C is also divisible by 9, then CBA will be divisible by 9. Got it? The addition of the digits is divisible by 9. Then the whole term will be divisible by 9. That whole term actually represents this CBA. Okay. And if A plus B plus C is divisible by 3, then CBA will be divisible by 3. Now it is very simple, as we have seen actual example first. Now this is very simple. Hence we can say that for the divisibility of 3 or 9, the sum of all the digits must be divisible by 3 or 9 respectively. Okay, got it? So this is a divisibility test for 3 or 9. Now let us solve some problems in the next part of this. Okay, now first problem, read it. Check the divisibility of 2, 3, 6, 5, 4, 7, 6 by 3 and 9. Okay, answer. For checking the divisibility of any number by 3 or 9, we need to find sum of all the of the number digits of this number. Okay, and check for the divisibility of the sum by 3 or 9. Okay, we have seen this in a divisibility test. Hence, for 2, 3, 6, 5, 4, 7, 6, we get 2 plus 3 plus 6 plus 5 plus 4 plus 7 plus 6 is 33. As 33 is divisible by 3 and not by 9, then this number given the whole number is divisible by 3 and not by 9. Okay, very simple test. Second one, check the divisibility of 4, 2, 5, 8, 4, 7, 9, 6 by 3 and 9. Answer, for this number we have to add all these digits. 4 plus 2 plus 5 plus 8 plus 4 plus 7 plus 9 plus 6 is 45. As 45 is divisible by 3 and 9, then that means the given number, what is this number, or whatever this number is divisible by 3 and also by 9. Okay, because this is a divisible by 9 also. So generally, if a number is divisible by 9, then it will be divisible by 3, as 3 is a factor of 9. But converse is not true. Got it? If any number is divisible by 9, it has to be divisible by 3. But if it's divisible by 3, it's not that it's also divisible by 9. We have seen it here. Okay? This is just a comment so that you can remember this. Okay? So you move ahead. Problem number 3. Read this very carefully. See, if 31Z5 is multiple of 9, where Z is a digit, what is the value of Z? Got it? We'll see the answer. As we know that for any number to be divisible by 9, the sum of its digits should be divisible by 9. We know this rule. We'll apply this rule. So 3 plus 1 plus Z plus 5, which is equal to 9 plus Z. Addition of all these digits is 9 plus Z remains. So 9 plus Z is divisible by 9 if Z equal to 0 or Z equal to 9. So that 9 plus 0 is equal to 9, which is divisible by 9, or 9 plus 9 is 18, which is again divisible by 9. So this Z has two values. So 3105 is divisible by 9, or 3195 is also divisible by 9. So all are divisible by 9. Okay. So next one, fourth one, we have taken the same number. See the fun of this. If 31Z5 is a multiple of 3, that is, this is divisible by 3, he has already given this, then where Z is a digit, what is the value of Z? Okay, similar. So answer, as we know that for any number to be divisible by 3, sum of its digits should be divisible by 3. Okay, so 3 plus 1 plus Z plus 5 is equal to 9 plus Z. Okay, so 9 plus Z is divisible by 3 only if Z equal to 0, Z equal to 3, Z equal to 6, or Z equal to 9. Okay, here it was only 2 because these were not applicable for this. See this, so that 9 plus 0, if Z equal to 0, 9 plus 0 is 9, or 9 plus 3 is 12, 9 plus 6 is 15, and 9 plus 9 is 18. All are divisible by 3. Okay. So for all these four values of z, the number form will be divisible by 3. So in this case, z has four values. Okay. So try to understand this, because you may come across such type of problems frequently. Okay. Fifth one, divisibility by 11. As we have been working like this, that we actually take an example and then try to work on it and then generalize the rule. Here also we are going to do the same thing. Consider any number. I have selected a 627 as number. Now in case of 2 or 5 or 10, a last digit was important. For 3 and 9, addition of all the digits is important. That was important. But here the case is totally different. Okay. Here addition is important, but not of all the digits. Here see, positions of the digits are very important. Okay. So this is the first position is odd, second position is even, third position is odd, like that. Okay. So even and odd positions are important. We were taking the number 627. Just go through this method. We have seen some steps in previous examples also. See, 627 can be written as 6 into 100 plus 2 into 10 plus 7. We know this. Now, unlike other methods, just see, 11 is written as 99 plus 1. We have seen this before also. Okay. But here, now, second digit, even plus digit, 10 is written as 11 minus 1. Okay. So we are not changing any value. We are just doing some adjustment or rearrangement. Okay. This is again 10 and plus 7. Now we are multiplying the brackets. 6 into 99 plus 6 into 1 plus 2 into 11 minus 2 into 1 plus 7. Okay. Remember this minus sign. So 6 into 99 plus 2 into 11, bring this together, and 6 into 1 is 6, minus 2 plus 7. Okay. Don't get confused, just try to follow this, and this is actually very easy. If you do it, don't do it mechanically, try to understand this. Okay. Now 11 is taken common, you get 6 into 9 plus 2. Okay. This term is divisible by 11 because it's multiplied by 11. Okay. Now about this term, 6 minus 2 plus 7. So we have written this step as it is, and 6 minus 2 plus 7 is 11. 6 minus 2 is 4 plus 7 is 11. This is divisible by 11 again. Okay. So this number is divisible by 11 as 6 minus 2 plus 7, which is equal to 11, is divisible by 11. Okay. Therefore, 627 divided by 11 is divisible by 11. We get answer 57. Okay. What does this gives the conclusion as, which means sum of digits at odd places. See, 6 and 7 are at odd places. So 6 plus 7, I have taken this like this. You may take add the odd digits and subtract even digits, like that also. So sum of the digits at odd places minus the sum of the digits at even places should be divided by 11. Then the whole number is divisible by 11. Okay. You will understand this if you try to solve some problems and try to understand it. This is actually very easy. Okay. And I'm taking some other examples. We have taken a 4-digit number also, so that you get better exposure for this and better understanding. Okay, so if you have followed this, we will move ahead. Now let us see the general form of this. Consider any number, for example a, b, c. A can be anything, b can be anything, c can be again anything. Now as you have seen, the positions of these digits are very important. So a, b, c are like this. Then positions are, this is odd position, this is even position, this is again odd position. So remember, these positions are very important for the discussion. Okay, so ABC can be written as ABC is A into 100 plus B into 10 plus C. 100 is written as 910 plus 1, A into 910 plus 1 into bracket, plus this 10 is written as 11 minus 1. Okay, so B into 11 minus 1 plus C. Now multiply these brackets with the respect to terms. A into 99 plus A into 1 plus B into 11 minus B into 1. Remember this minus sign, this is very important, and plus C. Now collect all this or bring all this together. A into 99 plus B into 11. We are rearranging these terms. What remains here is this A minus B plus C. Very easy. Okay. Now take 11 common, and we are left with A into 9 plus B. So this bracket is multiplied by 11. So this term is divisible by 11 plus A minus B plus C. And what is A minus B plus C? A is odd, B is even, and C is odd. Okay. So we have added odd terms and subtracted even term. Okay. Now you will see some rule under this. This number is divisible by 11 if A minus B plus C is divisible by 11. Okay, if this is divisible by 11, then the whole number, in fact this number, will be divisible by 11. Okay, which means the difference, this is a very important statement here. Numerical, do not consider sign. So if you find this addition lesser than this, then you take only numerical value, don't consider any sign. Okay, remember this, addition may be less if there is 1 here and 9 here. Okay, like that you come across it. So do not consider sign. Okay, so we'll read it again, which means the difference of the sum of digits at odd places and the sum of digits in the even places should be divided by 11 or divisible by 11. Okay, so we have to add digits in the odd place, again add digits in the even place. In this case there is only one, you will see it further. Then you have to check the numerical value, don't consider sign. Okay, got it? So this is divisibility by 11. Okay, let us look at another example, 4 digit, and you will get clear idea about this. Okay, so we move ahead. Now we are considering 4-digit number. Consider number 5192. So I am writing this number 5192 as it is here, and these positions are very important. I am denoting their positions odd, even. Now 5192 can be written as 5 into 1000 plus 1 into 100 plus 9 into 10 plus 2. Very simple. We are familiar with this. Now there is a turning point. See, 1000 can be written as 5 into 1001 minus 1. Okay, so added 1 here and subtracted 1 plus 1 into 99 plus 1 plus 9 into 11 minus 1 plus 2. Very simple. Now take this 5 inside. 5 into 1001 minus 5 into 1 plus 1 into 99 plus 1 into 1 plus 9 into 11 minus 9 into 1 plus 2. Okay, simple arithmetic calculations. Now take this 5 into, I'm collecting all now these terms together. 5 into 1001, okay, plus I am not collecting this, I am taking this term first. 1 into 99 plus, I'm not taking this, I am taking this term, 9 into 11. Okay, now I am taking the other terms, this one, this minus 5, this minus 9, and this plus 2. I kept them in a bracket. These are the all the terms we have taken. Okay, so now again I am taking 11 common from this. Left is 5 into 91 plus 9 plus 9. Okay, now plus, now see, I am taking some plus terms together, rearranging them. 1 plus 2 minus 5 minus 9. I'm just taking them together for some purpose. Now this term is written as it is, plus 1 plus 2, taking minus sign common from here, and to bracket writing 5 plus 9. Now if you see, this term is divisible by 11 because it's multiplied by 11. If this term is divisible by 11, then the whole digit or whole number will be divisible by 11. Okay, we will see practically what happens here. This number is divisible by 11 as 1 plus 2 minus 5 plus 9 is equal to minus 11. Therefore 5192 divided by 11 is 472. You have seen this. Okay, this is divisible by 11. This means, if you see, which means the sum of a digit at even places. See, I am writing it here, 1 and 2, sum of the digits at even places, minus sum of the digit at odd places, 5, 9. Okay, sum of the digit at odd places should be divisible by 11, then the whole number will be here. Number will be divisible by 11. Okay, so we go through it, try to understand this. This is very simple. Only some arithmetic calculations to be done, then we can get through it very easily. Okay, so moving ahead. Now here we are considering the 4-digit number in general form A, B, C, D. Any value they can be given. So write A, B, C, D like this. Write their positions. A is odd, B is even, C is odd and even. Okay. A, B, C, D can be written as A into 1000 plus B into 100 plus C into 10 plus D. Very easy. We have seen this. Now this 1000 is written as A into 1001 minus 1 plus B into 99 plus 1 plus C into 11 minus 1 plus D. Okay, you know this, you have done this in the previous example also. Now multiply this, A into 1001 minus A into 1 plus B into 99 plus B into 1 plus C into 11 minus C into 1 plus D. Okay, you know this. Now collecting all these terms together, which are multiples of 11. So A into 1001, I am not taking this term at present, taking this term B into 99, not taking this again, now this C into 11. Now considering all the leftover terms, this B minus A minus C plus D. Okay, no matter which is taken first, but you have to take all these terms, you cannot leave any term like that. Okay, so now take 11 common, so we get A into 91 plus C plus 9 plus into bracket consider positive terms together. B plus D minus A minus C, some rearrangement for some purpose. Now take this term, write this term as it is, plus B plus D, taking minus 1 common, A plus C. Okay, what do you see? See, if B plus D minus A plus C is divisible by 11, then the whole number is divisible by 11, because this term is divisible by 11, as this is as a 11 as a factor. Okay, this means, just see, go through this comment very carefully. Okay, which means difference, only difference, numerical, do not consider sign, of the numbers of the digit at odd places. See, only we are considering odd places, A and C, B and D. So A plus C should be there, A plus C, and B plus D, B plus D. We are talking only difference. Okay, so difference of the sum of the digits at odd places, this, and sum of the digits at even places, this, should be divisible by 11, and the whole number will be divisible by 11. Okay, it may so happen that this addition is bigger than this, still rule holds good for this. Okay, that's why it's talking only about difference, can take one other way around. Okay, so this is a divisibility by 11, and try to solve some problems on this, try to have enough practice. This is a very easy topic. Okay, but you need to have enough practice, and so practice, then topic becomes still easy. Okay, so still, if you have any difficulty, write to me in the comment section, and I will definitely solve it. This is Dr. Bharat Parab helping you in your studies. If you have any difficulty in this topic of test of divisibility, let me know through comment section, and I shall solve it or explain it again. Okay, thanking you. Good luck. Okay.